implies that the birth of the universe would involve the matter we're familiar with that produces atoms, and each of the particles involved has its antiparticle. And we know the antiparticles exist. You can make them in your kitchen, practically. We have, for electrons, there's an antiparticle called a positron. So if the universe was born in the way we think, we should have expected to see an equal amount of antimatter and matter produced at the same time. There's nothing unique about the stuff we're made of. But that's not what we find. We can detect antimatter in the universe by looking at the behavior of certain kinds of objects, stellar objects. There's no evidence there's antimatter floating around free. You can make it in the laboratory, and this is an active field of study, but where is it all in antimatter? Oh, and I should have said, when antimatter and its corresponding matter particle, when they get together, there's a little puff of energy, and the two objects are gone. The positron and the electron annihilate, and they're gone. So if there was an equal amount of matter and antimatter at the beginning, why is there anything left over? Should know all of it have canceled out. We don't know where it is. Now, it may be that all of it collected in one spot in the universe or in another universe. Deep question. This is my favorite. Why does mathematics work to describe the universe? Einstein would occasionally produce some interesting quote about this. It's a complete mystery. You got, for example, I'll just recount something I've talked about before. In the 1880s, the French were very prominent in mathematics, and Cauchy and Riemann, a German. But a lot of French, let's say this, a lot of European progress in abstract mathematics. They produce a thing called differential geometry, which is still a field of active study in mathematics, and just an intellectual exercise. 25 years later, Einstein's working on a theory of relativity. Luckily, he has a friend, Grossman. Grossman was an expert on differential geometry. And Einstein was thinking about relativity, but unable to make progress in writing it down. But Grossman said, oh, I know what you're doing there. That's differential geometry. Let me show you how it works. And 5 years later, Einstein had his masterpiece, the theory that describes how the universe works, his theory of gravity. But why does differential geometry, which is a conjuring of the human mind, have anything to do with physical reality? If we were going to start over, perhaps we would invent a different form of mathematics that is consistent with the way nature actually works, and all these questions would be answered. But the math we have now is partially working. Let me jump back. I talked a little bit about Freeman Dyson. Let me jump back to that and tell you something very interesting. The three guys who won the Nobel Prize each calculated the anomalous magnetic moment of the electron, which is a number. It's like 1.57 and a whole bunch of other digits. In the early 50s, after they had done the theory, in the early 50s, people measured the anomalous magnetic moment of the electron. And they got 1.57 and a whole bunch of digits. The theory and the experiment match to 11 decimal places. This is not an accident. It's good to 11 decimal places. We do not know the national budget of the United States. We don't know anything else. This is the most accurate measurement ever made. And it involved, as I said earlier, throwing away a bunch of infinities and doing it in the right way. Nobody knows why that was. So this thing about math describing nature, gravity and quantum physics, I don't know, you could put that in either column. Earliest times in the universe, right now, can we ever understand it? Right now, we understand the behavior of the universe starting at about 10 to the minus 30th seconds after the Big Bang. That's what they're doing in Switzerland, in Switzerland at the research center called CERN. They fire protons at each other, and they reproduce the environment of the earliest universe back to 10 to the minus 30th seconds. And they'll increase the energy, they'll go back to 10 to the minus 32, and so forth. But can we ever really understand what happened at the beginning? I don't know if we'll ever get there. How can we test inflation? I've talked about inflation as a theory of the very earliest universe. Is there a way to test this? Which is the only way you know the theory is right. This is why Alan Guth does not have a Nobel Prize. He predicts lots of what we see in the universe, but the Nobel Prize waits until there's some confirmation. So the question is, will Alan Guth ever get a Nobel Prize? What's the future? Which is, right now we think the universe will just keep expanding ever slower, but never stop expanding and never recollapse. That's the current theory. Joseph Silk's group thinks that a big crunch, which is where it just gets so big and then it comes back together, could happen. Yes, sir?
I think about these sorts of things frequently, and if you go back 1,000 years or so, for all fields of science, the list on the left would be huge. But people keep chipping away and finding out the answers. And one of the things that strikes me is one of the real virtues of science is that it's a converging enterprise. So that even things like the Hubble constant with 3 answers right now, that's going to get resolved at some point in the future. I'm pretty much convinced of that. I mean, I don't know whether these questions will be answered in my lifetime or our lifetimes, for sure, but I'm quite certain that most of them will be answered eventually.
Yeah, so I agree with what you've been saying. When I put these two lists together, I struggled. Which things go in the column of will we ever know the answer? Yeah, I think a Hubble thing will get fixed.
Yeah, and science takes a lot of wrong turns and blind alleys and things like that.
Yeah.
But eventually, it does converge on knowledge.
Here's what I say to young people. I could have quoted Steve. Science will eventually converge on things, but at every stage of the scientific enterprise, there are fundamental assumptions that are made by the working scientists of that era that are totally wrong. And I have a lecture I've given to mostly young people, like ages 8 to 15. Here are some examples where science just completely missed it. So I have a friend who was a geologist who lived here in Denver, worked for the Geological Survey, died just a few months ago. He was prominent in working on the problem of dinosaur extinction. He was a specialist in how impacts of large objects striking Earth produces certain kinds of mineral structures, one of which is called shocked quartz. Shocked quartz is unique. You only find it near impact craters and nuclear blast sites. And so anyway, he was an expert, and he's a fellow of the American Geophysical Society and all this stuff. He knew lots. And I asked him one time, what was the theory of cratering of Earth when you were a student, Bruce? And he said, well, he graduated with a PhD probably in 1952 or something. He said, if any geologist said in a public place that objects are falling from the sky and making holes in the ground, they would be ostracized. The public knew this was happening. If you go back into the late 1800s and look at National Geographic magazine, when it was just beginning publication, there's articles about Meteor Crater, Arizona. There's a hole in the ground, many of you may have been there. The public perception was that was made by a big stone falling from the sky, but the science community did not accept that until, and this takes a scientific revolution, until a prominent person who was trusted said, hey, we've been thinking about this the wrong way. And that person was Eugene Shoemaker, who in 1960, along with somebody else, said, there's a depression in Germany, near Munich. It's called the Rice Crater. I gave away the pen. The Rice Crater, R-E-I-S. The Rice Crater in Germany, that's not the result of a volcano or something, which were the ideas at the time. The volcanoes existed and they collapsed, and that's why there's holes in the ground, or depressions. Eugene Shoemaker and his colleagues said that was made by an extraterrestrial object striking Earth. That was 1960. And because Shoemaker had a reputation of excellence, people stopped and listened. Thomas Kuhn, K-U-H-N, wrote a book about this called The Foundations of Scientific Revolutions. The old people have to die and get out of the way. So when I talk to the young people, I say, how come nobody believed Wegener, who back in the 1910s said, hey, I've noticed if you take South America and Africa and fit them together, it fits. Could they have been part of the same thing that separated? A child, a 7-year-old with a pair of scissors and a paper map can come to the same conclusion. Wegener was dismissed from any serious scientific conversation. The list is endless. I should post that lecture on my website of the idea that, yes, science is a random walk, and it just, professionals get in the way sometimes. Like the idea, a completely different area of study is ulcers, human ulcers, stomach ulcers. 2 guys in Australia said, we don't cause stomach ulcers. It's not stress at work. It's a bacterium that can survive in your stomach. And everybody said, you idiots. There's no way a bacterium can survive in the stomach acid. They were laughed off the stage at medical conferences. Then they won a Nobel Prize because people found the bacterium. So, yes, Steve is right. Eventually we'll solve many of these problems. The question is, how do we stop the groupthink? So my challenge to the young audiences when I talk to them is, you guys, you 10-year-olds, you have to figure out what stupid thing we're thinking right now. It's just obvious to them. It should be obvious to everyone how wrong-headed we are, and yet we don't give up. We keep embracing these bad ideas, and it delays progress. Yes, sir?
In regard to the Heliobacter.
Yes.
In the stomach, another reason why that was fought were all the drug companies that sold Maalox and all the other stress medicines. This is a multi-billion-dollar business.
It's not Maalox, which is over-the-counter. It's there is a prescription medication that ulcer sufferers use, and it is that one drug is a multi-billion-dollar drug. Oh, those 2 guys, they were from Australia, and they just had a terrible time until finally the people took them seriously. Another one is, we're almost ready for a break. Another one is sometimes called cat fever. Humans can contract a virus. I'm working on this now. While I'm talking to you, I'm trying to think of the name of this. Cats have the ability to digest animals that have this virus, and the cats don't get sick, but their feces have the virus. and people that come in contact with the feces, humans, get sick. And this is a relatively recent thing, like 20 years of study now. This has the effect of a predator mammal of the following things. Like the cat has the bug, but it doesn't make them sick. The mice that are around get the infection, and it changes their brain function, and they love being around cats. This is probably the reason we occasionally have a news article, including around here, of the so-called cat ladies. You go to their home, and there's 120 cats in the house. They are playing, the woman, or the man who's infected, is playing the role of the mouse. But the cats are not big enough to kill them. So this bug causes other mammals to be attracted to cats, cat urine, cat odor. So if you're a mouse, if you're smaller than the cat in your home, the cat will kill you, and it doesn't bother the cat. The cat's fine. Well, let's have a break. Pam may have some announcements.
Yep, so the attendance sheets over there, if anybody has their parking passes and hasn't given them to me, I'll take them if you do not have class, on Monday. This is the last week of classes for Tuesday and the Thursday, but most of the Monday classes will have one more next week on the 9th. Online evaluations should be in your inbox, in your email, by the time you get out of class, which is what's been happening to me. And if you could complete them, the feedback is very helpful. Spring term class confirmations will go out on March 16th. If you are not confirmed until you have received this confirmation. And the spring term starts on the week of March 30th. And that's about all.
So let's have a break for 10 minutes. I got lots more to talk about today, so let's not have a long break.
I guess because I live south, I thought, oh, I only want to look at the ones that are
Yeah.
convenient to me. But
You just have to go in, if you're doing it online, you just have to click to each one.
Yes, I saw this. I decided not to talk about it because there's so much other stuff to talk about.
And then.
Well, they don't really explain what caused the explosion.
No, I know. It's
So if you're, but they must talk. I mean, I
So
know the three
large.
that are together do. So they won't
15
charge
Milky
you
Ways.
oh,
It is. Yeah.
okay, yeah. I
5
didn't realize
times
that
was
then.
bigger than the previous
But then I
record
decided
holder.
I've got a lot of yard
Yeah.
to do in the spring, so maybe I'll skip that for now.
I'm skipping spring for skiing,
Um,
because it's so nice skiing right now.
I don't know.
Okay.
I read little news articles.
It says black holes don't just draw matter in, they also blast
because he's
out
talked
jets of
about it.
Yeah,
material.
yeah.
Well, that's from the
Accretion disk.
accretion disk. yeah.
Right, so see, this is an example of where, I'm sure she's a good reporter, but this language makes it sound like the black hole itself is spewing
Right,
out
right.
stuff, and that's not what's happening.
Well, it's from the Astrophysical Journal, and she probably didn't understand what she was reading.
Right, well, this, see, normally, if I have time to respond, to follow up on these kind of news articles, I go to here and read the abstract.
Yeah?
Yeah.
And for most people in this class, you can read the abstract and understand it.
Yeah.
Well.
Yeah, I saw this in the news,
Were you really?
and I'm distracted by this cat thing I was talking about. I'm sorry.
I was real good at
Well, that's interesting, I never knew why people would have that many cats.
Yeah.
It's a really interesting disease that
Well, I
was
remember
first
going home and
identified
talking to my
in
parents,
Eastern Europe.
saying, I have to pick a major.
Around the time of the fall of the Iron Curtain.
Well, you're like,
People
well,
didn't
math
take it
is- I
seriously.
like math. He's like,
but it's a real issue.
I thought you had to do a heart
with
major.
mental
get
illness
hard.
in the United
It
States.
did.
There's some,
Differential equations
the
is what
feeling
people
is there's
said.
some substantial fraction of people
I did not think that
with-
was easy at all.
with
I also didn't think
psychosis
geometry was easy.
because they have,
So it was very, calculus was no problem.
grew
Went
up
to
with
PQ.
cats and they got the
In the state of
disease.
New York, they have,
And it has
uh,
changed their
state
life.
exams.
The other thing is that animals that have this infection
Yeah.
are reckless.
Regency's names.
That not only are they attracted to
Yep.
cats,
And,
they will do anything dangerous
Yeah.
to get
Yeah.
to the cat if one's in the neighborhood.
One was in geometry.
And I actually have an acquaintance who is
Geometry, and
out
one
of
was in,
control,
Chemistry, no, chemistry.
an insane driver,
Constantly.
constantly making bad choices about money and so
It still
forth.
bothers
And
you.
I once asked his wife, his ex-wife, did he grow up with cats? She said, oh yeah, the house was full of them. Now, I can't make a diagnosis, but
Well, I was real good at math.
It's
through
an
high school.
intriguing
Of course, I had to
possibility.
Right.
take math classes all the way through college and then master's degree. But
I have it now.
used-
toxoplasmosis
It's worth
is
it.
the name
I've
of
still
the,
got some of my old
of
math
the cat
classes. I'm tempted to
disease.
go back and-
I'll tell you, there's a prominent person who was,
Sit and see what-
was
see what I
afflicted
can
with this,
remember,
and that's
see if I can
Martina Navratilova,
solve some of the problems.
tennis player.
Yeah.
You know, I thought-
She
what
was-
do you do with math?
Had to undergo serious medical treatment. She had a very bad case. I mean, not the mental part, but she had a bad
Well, my
immunological
dad was like, oh,
response.
you can do math anywhere.
It took a while to diagnose, and it turned out she had toxoplasma. She
Okay.
had cat virus.
Uh,
So,
I was like,
Never heard of
that
But he
my
was an
favorite.
engineer, so
Oh,
that's why he
bias.
said,
That's his
you can do
bias.
it anywhere.
That was his bias.
Exactly.
I thought they're quite the opposite. I thought it was the other way around. So the closest thing to that was chemistry, and so biochemistry.
I got that at the Science Museum last week.
yeah,
Whenever I'm over at the Science Museum, I go through the
Yeah.
store,
Right.
and I look at the books they've got, books of jigsaw puzzles.
Yeah.
Yeah.
I
Okay, great
love-
equations.
I
If you
have a
read
bunch
it,
of jigsaw puzzles too, and I realized when I'm in the middle, I could figure it out. Am I wasting your time here doing your
Well,
demonstration?
I don't know, I mean, a jigsaw puzzle involves a lot of your brain. You know, you have to have the sense of geometry and shapes and be able to spin them around in your mind.
That's what I like, but I'm in the middle of jigsaw puzzles, and I'm saying, wait a minute, I'm wasting my time, right? I'm spending all this time doing a
Yeah.
jigsaw puzzle. I love the same
But-
way you do.
But it doesn't do any harm to do it.
Well, except it takes your time.
well, the same thing, a crossword puzzle.
Yeah.
That's what I do. I bought a subscription to the New York Times electronic crossword puzzle thing.
Oh, yeah.
And I went back to the first puzzles that became available in electronic form in 1993. And I am doing every one of them. I'm in 1996 now. So I've done hundreds and hundreds, perhaps thousands. And you have to have cultural knowledge. Like, who was the host of The Price is Right in 1993? It wasn't whoever's doing it now.
Drew Carey's doing it now.
Drew
but-
Carey's doing it now, but it was like
Bob Barker?
Bob Barker, yeah. So you had, and I made a terrible mistake years ago. I bought a collection of New York Times crossword puzzles published when they started in the 1920s. No chance. You have to know who was the Secretary of Treasury under Herbert Hoover,
Like, and you don't.
and I don't. Now,
It's a personal feeling.
Will Shorts,
Real short, he's-
Will Shorts, who is the genius behind crossword, all their puzzles at the time, says, you're not supposed to do it without looking stuff up. I never look stuff up. But I do use the version where you can turn on the error detection. So I work on the puzzle for 10 minutes, make as much progress as I can, and then I turn on the feature that shows you where your mistakes are. But I never look anything up. I just, like if it's the Secretary of Treasury in 1927, I have to build that word out of
Yeah,
the
yeah.
intersecting words.
You know, there's another type of puzzle in the New York Times called Ken. You ever hear of Ken?
Yeah.
No.
It's a number of puzzles, and it starts off easy on Monday, and it gets